Hi, my name's Alan Smith, and this is one of a series of webcasts hosted on bloggersguides.net looking at working with BizTalk Server 2009. Although I'm using one of the betas of 2009, this should work okay in BizTalk Server 2006 Release 2, working with the WCF adapters. I think the only thing I'm using that's 2009 specific is the administration tool for using instead of the health and activity tracking tool. What I'm going to be looking at in this webcast is transactions and compensation in BizTalk Server 2009. I've got a sample I've been building in a couple of previous webcasts when I was looking at the orchestration reliability and building a service aggregator pattern. So you can check out those other webcasts to see the actual basis for this design. What I'm going to be looking at is the orchestration transaction model, how we can add compensation code to transactions, and then how the transactions can actually be called. I'll explain a bit at the end of the webcast. My scenario probably isn't a real world scenario, and I'm not doing any exception handling. What I'm looking at here is just the mechanics of how compensation works within an orchestration. So the scenario is basically a client which is calling a service aggregator, which is implemented as a BizTalk server orchestration. Then we're making calls to a conference service, a flight service, and a hotel service. We make those bookings in parallel, so it's a fairly efficient process. We get back our responses, and we return that response back to the client there. So we looked at in the reliability section about what happens if one of the services is down, and we've got the retries in the send and receive ports, so we can actually retry calling a service. But in some scenarios we may want to do that. Retry adds a lot of latency to our service, because it may take 5 minutes before we actually call a retry, and we may want to actually return to the client very quickly if there's an issue with these services. Also, retry logic can fail after a certain amount of time if the service is down permanently. Then we're going to get errors. Or if we send something that is generating a fault message in the actual service, there's no real point in retrying that send there. So this is how things are going to work in my scenario. I'm taking my response in. I'm calling the book method on all three services, and I'm getting responses from the conference service and the hotel service. But because the flight service is down, we're not getting any response there. So what the orchestration then is going to have to do, it's going to have to actually cancel the conference and cancel the flight, because we haven't been able to book a hotel. So I will need to send these cancel messages there out to the conference service and bring back the actual responses there, and then send an actual fault back to the client. Maybe not a fault, maybe just a message describing what's happened, that we couldn't book this because there was a problem calling the flight. Now you could do this with all kinds of exception handling and constructing and sending out other messages, but what I'm going to be doing is leveraging the orchestration's compensation model to be able to have the orchestration automatically call whatever service has succeeded in the event of any service failing. So it's going to call the cancel method on anything that it has booked if one or more of the services fail. So this is the orchestration that I'm starting with, and I've used this sort of design in a couple of other webcasts. In the Service Aggregator webcast, I started off the design and then made it more efficient by adding the parallel receives and parallel sends, so we're calling the services parallel in the orchestration performance webcast. So this is the actual design of the orchestration. What's happening is a message is coming in, and we're basically making calls out to these three services here. We're going to be booking a conference, booking a flight, and booking a hotel. And here's where we construct all three messages for those sends. And it's an atomic transaction that we're doing the sends in to reduce persistence, and then the parallel receives to pick up the actual responses that are coming back in. So the idea here is to call these services transactionally. And I've got an atomic transaction here. I'm just going to show you a bit about some of the limitations here. If I drop on a new scope shape and just change this transaction type to atomic, and you may think if you're using something that is transactional, like maybe the SQL adapter, that you can go in an atomic transaction, you can actually send a message out and you can receive the response there within an atomic transaction. And if I do a build here, we get an atomic scope may not contain or call a service or scope that contains both the send and corresponding receive of a request-response operation on a user's port or service link. Quite a complex error message, but what it's really telling us is that this design won't work with an atomic transaction because we're sending the message and we're receiving the response here. But this message will not be sent until the atomic transaction commits down here somewhere where we get this persistence point. And because that won't happen, the transaction can't commit until we've actually received the response, and it will never be sent until it gets down here. So we're basically locking the orchestration if the orchestration compiler would allow that. So I'm just going to press Ctrl-Z to remove that and get back to the original design. So what I think I need to think about doing is doing sort of a more long-running and compensation operation here. I think Isaac Newton said for every action there's an equal and opposite reaction. And when thinking about transactions, I think for every transaction there should be an equal and opposite compensation. So what I'm going to do is basically use some transactions down here. But I'm going to use them when we're actually receiving the messages. And these are going to be long-running transactions. And then I'm going to start adding compensation code. To compensate something, we basically undo the effects of that transaction. So I've got a cancel conference, cancel book flight, or cancel flight booking and cancel hotel booking here. And I can call these methods to actually cancel the bookings that I've made in the actual orchestration. And we should see that appearing in the actual window when we're actually testing the services. We'll hopefully see the actual numbers decreasing as we make calls and cancel those services. Okay, so in this block in the parallel actions, I'm going to drop in a scope shape. I'm going to set the transaction here to be long running, and I'm just going to move up the book conference shape into this scope shape. I'm now going to add a compensation block to this. Now this compensation block is going to be called if this transaction completes successfully and then something else fails within the orchestration. It can either be called automatically by the orchestration engine, or I can actually manually add an exception handler and call compensation code there. So what I want to do is to basically make a call out to the cancel flight booking method there. So I can actually cancel and roll back the flight. It's actually going to be the actual cancel conference method there, because this is receiving from the actual book conference. So to automatically construct my web methods, I'm going to drop in a send and a receive shape here. Then if I zoom out a bit, I should see that port appearing in the actual orchestration designer as well. And I can make my links. So what I'm going to do is basically link these send and receives up to this port here. And if you saw my webcast previously, you'll know that that's my chosen method for automatically generating these messages. So I've got two messages here, and what I'm going to do is just rename these. So instead of book conference request, it's going to be cancel conference request. And instead of book conference response, we're going to have cancel conference response. Okay, I'm just going to drop back to 100% and start to think about constructing my messages here. So before I actually send this message, this will actually error out with use of unconstructed here if I do a build. So what I need to do is actually construct the message that is going to cancel the request here. So I'm going to drop in a transform shape. And configure this to actually construct the message, and I'll be generating a new map here. So we are going to be constructing the cancel conference request message. And I'm going to generate a new map called conference booking to cancel conference request. My source message is going to be the conference booking message. My destination message is going to be the cancel conference request message there. And I'm going to just new up a map in Visual Studio. So I'm just going to expand these two guys and go in and set these. This is fairly easy to map. We need the attendee name. We need the booking ID. We need the conference name. The end date I can get with add days functoid, and that's going to be the start date plus the number of days duration, so that's going to go to the end date. Then we've got the conference ID that I can map across there, location from there, and start date, we've got that there already. So that should be fine for my map if I save this. So hopefully I've got the compensation code built in for one of my transactions here if I scroll down. So it's basically saying if I book the conference, the action to undo that conference booking is to construct a cancel message and then actually call the ports to actually cancel that and call this method up here. Now what I need to do is to add that code for the other 3 transactions. So I'll just basically start this procedure and then pause the recording as I build up the rest of it. So I'm going to have a transaction here. I'm going to insert the scope shape and set this to long running. Drop in another scope shape and set that also to long running. And I'm going to move these 2 receives up into this actual message. It seems a bit strange having the receive shape there, but it's this shape that's going to generate the exception if something goes wrong with a web service. So if we receive this successfully and this transaction commits without an error, it's then that we want to start calling the compensation code there. So both of these are going to have new compensation blocks on them. And I'm going to start actually wiring these up to the services. So it's going to be exactly the same code as I'm putting in here. I make a call out to the cancel for the flight service and the cancel for the hotel service, and then also construct those messages. I'll pause the recording while I do it, and I'll also rename the shapes in the orchestration. Okay, so I've added that code there, the actual compensation shapes in the orchestration for the 3 transactions, and wired them up to the method. So I'm just going to zoom out a bit so you can see the full picture of the orchestration. So what's happening is that we're receiving a message, we're constructing these 3 requests for our web services. We're making out calls to these 3 web services in parallel. And then also in the parallel actions, I'm basically receiving the 3 messages there. So the idea behind the compensation code is that if anything fails here, if one of these services fails, that's going to generate an exception in the orchestration, and we're going to basically jump out here. I've got no exception handling code in the orchestration. What I want to demonstrate here is what happens when you get an exception in the orchestration when you've got transactions and compensations. And in a real-world scenario, we would put in some strong exception handling code so we can handle what goes on here. But I just want to explore the mechanics of what happens here. So if the flight service fails, for example, and these 2 do complete successfully, these transactions will have committed successfully. And when this one fails, it won't have committed, so the orchestration engine will detect the exception. It will run through its list of transactions and it will say, okay, what do I need to undo to get the process back to a normal state? So hopefully it will call compensation code on the flight and the conference operations, and we should see those actual cancel methods made here. And when you're seeing this in the window, we should see the numbers decrease as it starts to call those cancel methods. So what I'm going to do is just deploy this to Visual Studio, and then I'm going to actually run a couple of tests on this. So I'm just going to start the deployment now. So I've got my orchestration deployed now, and I'm ready to start testing. So you can see that this was my original design. Then when I optimized it, I had the book attendee parallel, and then I've got the book attendee compensation. So it's this, the one with the transactions in that I've got started, and the other 2 are enlisted. It's connected to exactly the same ports as the other one, so I can just switch in different orchestrations there. So I'm going to start off the client application here, or the actual service host. Now this is a Windows Forms application hosting my 3 services, and I can start these 3 services. So it's easy for us to see basically what's happening when we're making the calls to this service. So what I'm going to do is to actually take the happy path now, where all of the services are up and running, and send through the conference booking. And you can see as I do that, we get the services being called there, and there's 3 services that have been called, and we've got 3 confirmation messages coming out there. Now I can experiment with taking down services. So if I take away the flight service and send through the message, you can see that these go up to 4, and then after a couple of seconds they go back down to 3 again. And this is the compensation code kicking in and basically calling the cancel method on those services. The implementation from those cancel methods is just decreasing the number that we've got booked. So I can start the flight service, Everything's working fine again now. Stop the hotel service, and these are going up to 5, and then going back down to 4. And it should be the same thing if I do it with the conference service. Those two go up to 5, and then compensation kicks in and they go back down to 4. And I could even stop 2 services. And hotels booked goes up to 5, and then back down to 4 again. So it seems that the compensation is working correctly for me. I'm not getting any messages coming out here. And if you go in the group hub page and I run the query, you can see that I'm getting all my orchestrations being suspended. So I do need to go in and I need to start adding some exception handling there. So what I'm going to do is just cancel these guys. If I take the terminate instances here and run this query. And I can go into my query, which is the tracked service instances, and I'm going to limit this to the service class being an orchestration. And you can see these are the ones that have actually terminated. So I'm going to open one of these in the orchestration debugger so we can take a look through this. All of this stuff I'm using BizTalk 2009, one of the betas, and all of this stuff will work in BizTalk Server 2006 or 2004, but you will need to use the health and activity tracking tool instead of the management console to get this view. So here we can actually run through and see what happened when I actually ran through my orchestration here. We receive the message, we construct the message, we make these 3 calls, and that's being done as an atomic transaction, so that's sort of one atomic operation here. We then go into our parallel actions shape here, and we're going to start calling our services, or start actually receiving the responses from our services. So we're basically initiating the 3 transactions here. And the shapes go green when they start and blue when they actually complete. So here we can see we received the message from the conference. We received the response from the flight. But now you can see that we're actually going into the compensation code now, because we never received the actual response from the hotel scope, or we received a fault message and we couldn't contact the service here, so that generated an exception here. So what we're doing is we're starting to run the compensation code. And the way that compensation works is that when we get an exception in the orchestration, if that exception is unhandled, the orchestration engine will automatically call compensation code on all completed transactions, and it will do it in the reverse order that they completed. So you can see that if I go up a bit, it was the conference that committed first, and then the flight transaction committed. So it's going to be the flight compensation that gets called first. So we're constructing the message, we're cancelling the flight, sending that message through to cancel the flight, and then in the conference we're constructing that message and calling the actual compensation code. I haven't got that information tracked because some error occurred in my orchestration, but we see from the actual forms application that we did actually call that method, and the transaction did roll back. So my compensation works fine. That was what I was aiming to demo in this webcast. Obviously, according to my design, I need to add some exception handling there, but I can definitely leverage this compensation mechanism to ensure that anything that happened within my orchestration, anything that committed, any transactions committed, do get undone or compensated automatically by the orchestration engine. So summary, to misquote Isaac Newton, for every transaction there is an equal and opposite compensation. And that's what you can think about when you're actually building your orchestrations. If you want compensation code to work, when you build a transaction, add a compensation block, and then add code that it is going to undo the effect of that transaction. You saw in my example I wasn't adding any exception handling, so I didn't actually go into doing all of the error handling. I just wanted to demonstrate the mechanics of how this works. And we saw that the compensation code was called automatically in the event of an unhandled exception. I didn't need to explicitly use the compensate shape to say compensate this or compensate that. Compensation is only called on transactions that completed successfully, so the orchestration engine, it persists its state when a transaction completes, and it uses those persisted states in the message box database to actually walk back through all of the committed transactions in the reverse order that they committed, and then call the compensation code on those transactions. So compensation is great, but you can have issues with it with compensation. I'm making the assumption that I can just call cancel flight and that is going to cancel the flight for me. But there's all kinds of business rules about when you can cancel a flight on budget tickets. Maybe you can't cancel that flight, you don't have that option. And there's all kinds of date-specific things, like you can cancel a flight on certain days, or maybe you should actually rebook a flight, and all kinds of things relating to the hotels and the conferences about when we can cancel. Also, what happens if the compensation code fails? We attempt to cancel a flight or cancel a hotel, and there's an error with that service. We need to think about error handling there. So compensation is a great way to add reliability to our orchestrations. It's kind of like doing exception handling using a try-catch block. But it works in a different way, in that in a try-catch block, if something goes wrong, we can undo the effects. But in their compensation code, if something goes right and the transaction does commit, later on in the orchestration's life cycle, we have the option to actually roll back that transaction if we need to.